Good morning, students. In the last class, we discussed some of the examples on Cartesian product and exercise examples of 2.1. So some more examples are remaining in the exercise 2.1. We have to discuss first. Afterwards, we'll go to relations. Okay. So in that exercise 2.1, one question is what? Find whether the following statements are true or false. If the given statement is false, write that in correct form. Okay. So what is the next question in the exercise 2.1? State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. That I told. Okay. First statement is what? If P equal to Mn, Q equal to Nm, then P cross Q Cartesian product is M comma N, N comma M. Is it true or false? See here, how many elements P have? Two elements. Q have two elements. The number of elements P cross Q equal to 2 into 2 means 4. Here only they are given 2. Therefore, the given statement is not correct or incorrect. Okay. The given statement answer is the given statement is incorrect or false statement. Correct statement is what? P cross, that is P cross Q equal to M comma N, M comma M, N comma N, N comma M. This is the correct statement. The given statement is incorrect. Therefore, correct statement is P cross Q equal to M N, M M, N N, and M. Okay. What is second question? If A and B are two non-empty sets, then A cross B is a non-empty set of ordered pairs x comma y such that x belongs to A, y belongs to B. Yes, it is the definition of the Cartesian product. As you know yesterday, what is the definition of the Cartesian product? If A and B are two non-empty sets, then A cross B have elements x, y such that this first element is from set A and second element is from set B. Therefore, this given statement is true statement. Okay. So, second statement is correct. Third one, if A equal to 1 comma 2, B equal to 3 comma 4, then A Cartesian product B intersection pi is empty set. Yesterday you know that if n of A equal to P, n of B equal to Q, the number of elements from A cross B is PQ. If one of the set is empty set, then A cross B is also empty set. If one of the set is infinite, then Cartesian product is also infinite set. See here, B intersection pi. B intersection pi, intersection means common elements from set B and pi. This pi is the empty set. So therefore, B intersection pi is also empty set. A cross pi is again an empty set. Because one of the set in the Cartesian product is empty set, then Cartesian product is also empty set. Already know one of the remark. Therefore, the given statement is again true. Okay. Therefore, the statement is correct. Okay. It is true statement. So first one is false. Next two are correct statements. Okay. Next question. Next question. The Cartesian product has 9 elements. Cartesian product has 9 elements, among which are found minus 1 comma 0 and 0 comma 1. Find the set A. Find the set A and remaining elements in A cross A. Remaining elements in A cross A. See, what is the next question? The Cartesian product has 9 elements, among which are found minus 1 comma 0 and 0 comma 1 are the 2 elements in A cross A. Find the set A. See, Cartesian product has 9 elements means, as you know that number of elements of A cross B equal to P cube. That product of two number is 9 means it should be 3 into 3 equal to 9. Therefore, number of elements of the set A is 3. Okay. So in the set A, there are 3 elements are there. So among which are found, okay. Find the set A. First part is what? Find the set A means first how many elements A has? 3 elements, because A cross A has 9 elements. Product of two positive number is 9 means A should be 3. Therefore, first what is that? See here. N of A equal to 3. Then only N of A cross A equal to 3 into 3 is equal to 9. That is why number of elements in set A equal to 3. So in that A cross A, two of the elements are minus 1 comma 0, 0 comma 1. So these are the two elements of Cartesian product A cross A. See that A cross A is obtained from the set A having 3 elements. It means that elements, that first element and second elements are from the set A. A having 3 elements means here. So how many elements are there? Here minus 1 is one element and 0 is another element and 1 is another element. So these are all elements of the set. These are in that order pairs. That first and second elements are from set A. Therefore, A having 3 elements, how many distinct elements are there in these two order pairs? Minus 1, 0, 1. Therefore, A equal to minus 1, comma 0, comma 1. Minus 1, comma 0, comma 1. Are you followed? Because A have 3 elements in that order pair, first and second elements are from the set A. How many distinct elements are present in the set in the order pair minus 1, comma 0 and 0, comma 1? Minus 1, comma 0, comma 1. These are 3 distinct elements in these two order pairs. And the second one is what? Remaining elements in A cross A. Remaining elements in A cross A means here 2 are given. You have to find still 7 elements. Therefore, remaining elements are first I want to find A cross A. A cross A equal to what? Minus 1, comma minus 1, minus 1, comma 0, minus 1, comma 1, 0, comma minus 1, 0, comma 0, 0, comma 1, 1, comma minus 1, 1, comma 0, 1, comma 1. First, I want to find all the elements of A cross A. There are 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are here. Okay. So among that, 2 are given. Minus 1, comma 0 and 0, comma 1. Minus 1, comma 0. Okay. This is given. And 0, comma 1 is also given. 0, comma 1 is given. Therefore, remaining elements are remaining elements are minus 1, comma minus 1, minus 1, comma 1, 0, comma minus 1, 0, comma 0, 1, comma minus 1, 1, comma 0, 1, comma 1. Okay. So 1, 2, 3, 4, 5, 6, 7. 2 are given. In this, you have to calculate the set as well as remaining elements of A cross A. Okay, this is again one question based on the Cartesian product. Okay, next is order triplets. Till now only you got A cross B. Okay, what is A cross A cross A? Okay, say suppose what is the meaning of A cross A? This is equal to A comma B comma C such that A comma B comma C belongs to A B C is called ordered triplet. See, order pair. Order pair means only A cross B or A cross A. Here it is ordered triplets. So you have to find the Cartesian product of three sets also now. Okay, you have to discuss how to find Cartesian product of three sets. If A having A B C, so this A B C is called ordered triplet. Okay, first question: if P equal to, so very few examples are there, ordered triplet is not easy to write. That is why P equal to 1 comma 2, find P cross P. First you have to find how many elements P cross P have. So again it is in the same way, n of A into n of B into n of C. Okay, same procedure as in the Cartesian product of A cross B. Here P having how many elements, sir? 2 elements, sir. Then number of elements of P cross P is 2 into 2 into 2 means 8 elements. Therefore, you would write P cross P. Okay. P having 2 elements, then you have to find P cross P. It means n of P into n of P into n of P means 2 into 2 into 2 is 8. As in the same as Cartesian product of ordered pair. It is ordered triplet. Okay. P having only 2 elements are there. You would write all the elements. Okay. Again, first here I'll start with 1 comma 1. Okay. 1 comma 2 and 1 comma 2 comma 1. 2 comma 1 comma 1. Okay. Now next I want to take 2 comma 2 comma 2, 2 comma 2 comma 1, 2 comma 1 comma 2, 1 comma 2 comma 2. You have to write all combination of elements 1 and 2. Here 1 1 1, 1 1 2, 1 2 1. See here, all are 1 here. It is not easy to write that. Otherwise, first, so one more method. How to remember this one? To write like this. Okay, it is not easy because you have to write all the pair of combination of elements you have to write. Otherwise, or you can write directly. First P cross P you have to write. P cross P means nothing but what? 1 1, 1 2, 2 1, 2 2. You have to write first. Okay, directly you can write like this or P cross P you have to write. Next, directly you can write P cross P. P cross P having again 1 comma 2 is there. Therefore, 1 1 1 1 you have to start with 1. You have to add 1 here. 1 1 2, 1 2 1, 1 2 1, 1 2 2. See here for all the 4 elements I added 1 here 1. Next you have to add one more element of P is 2. Therefore 2 1 1 for this one. Okay, 2 1 2, 2 2 1, 2 2 2. Okay, how to write? What is the trick to write like this? It is not easy to write all the combinations sometime. Okay, that is why you can write directly this first. Otherwise, you have to write P cross P. P cross P means 1 1 1 2 2 1 2 2. Here I wrote no. Next, if you want to write P cross P means first element I want to take here 1. See 1, 1, 1. These elements again I will write here 1, 1, 1, 2, 2, 1, 2, 2. So nothing but what it is, you have to write all the combination of elements. Okay. So again one more element is what? 2 is there. 2 again 1, 1, 2, 1, 2, 2, 2, 1, 2, 2, 2. Okay. In this you have to write P cross P cross P. So order triplet is not easy to write. Okay, that is because you have to write all the combination of elements. Okay, in this you have to write P cross P cross P. One more example. If A equal to minus 1 comma 1, minus 1 comma 1, minus 1 comma 1, find A cross A cross A. Find A cross A cross A. Again, I want to find order triplets. Okay. You can write directly A cross A cross A equal to C. I write all pair of combination of the elements. Minus 1, minus 1, minus 1. Minus 1, minus 1, 1. Minus 1, 1, minus 1. 1 comma minus 1 comma minus 1. Here first minus 1, all are minus 1. Here third element I will change it to 1. This one I want to put into different form. Here 1, here 1. Again I will start from 1 comma 1 comma 1. 1 comma 1 comma minus 1. Okay. 1 comma minus 1 comma 1. Minus 1 comma 1 comma 1. You get all the pair of elements. 1, 2, 3, 4, 5, 6, 7, 8. It means one more remaining. Okay, 8 only will come. Okay, 2 into 2 into 2, 8. Okay, in this way I would write order triplet. So what this represents? So Cartesian product. Okay, suppose if you take R cross R is a real number, x, y, such that x comma y belongs to R represents all coordinates of a point in a plane. What this represents? R cross R is nothing but a real number. If you take Cartesian product of the real number, if you have x comma y, xy belongs to R represents all the points in a plane. Plane means what? Space means what? I already know that. Plane means two-dimensional geometry. Space means three-dimensional geometry. This x comma y represents points in a plane. If you have R cross R equal to x comma y comma z, x y z belongs to R represents points in a space. Okay, points are the points in a space. This represents points in a plane and this represents points in a space. So this is all about the Cartesian product. Cartesian product, how you can define okay, A and B are two non-empty sets. Then Cartesian product of A and B is the set of all pair of elements from set A and set B. Okay. So next you have to discuss a relation. What is relation? So by taking one example, I want to define relation. For example, here, if A equal to 1 comma 2 comma 3, B equal to 2 comma 3, I will take. Okay. Next, A cross B. That relation is also depend upon Cartesian product. A cross B is equal to what? 1 comma 2, 1 comma 3, 2 comma 2, 2 comma 3, 3 comma 2, 3 comma 3. Okay. So this is the Cartesian product of A and B. Now I want to write one relation set here. Just I want to take first one example. Suppose I will take R here. R equal to, I will write 1 comma 2, 2 comma 3. Okay. Only I took these two elements from the set A cross B. So this is the set builder form. Okay. Sorry, roster form. I want to write this is in the set builder form. How I will write now? See here, R is a relation. See R, nothing but relation. So this I will write it as x comma y such that x belongs to A, y belongs to B, y equal to x plus 1. See here, R is a subset of the Cartesian product. Again, I took these two elements from the set A cross B. Here, there is a relation between first and second element. What is the relation between first and second element of the order pair? See, 2 is greater than 1 by 1. 3 is again greater than 2 by 1. That I want to write in the set builder form as y equal to x plus 1. So this is one relation. Suppose I will write one more relation. If you write one more relation, see here, what I want to write. See, 2 comma 2, 3 comma 3. I took only these two elements. Okay. So this is the roster form. If you write this one in set builder form, again x comma y such that x belongs to A, y belongs to B. What is the relation between the first and second element here? X equal to y. This is again one more relation set from the Cartesian product. It means what? How we are writing that the order pairs from the A cross B, they have a common relation between first and second element. Here y is greater than x by 1. Here x equal to y. Again I want to write one more relation from the set A cross B. You can write more number of relation from A cross B. One more is what? See here, I write 1 comma 2, 1 comma 3, 2 comma 2, 3 comma 3. What type of relations here? I didn't write 2 comma 3 and 3 comma 2. Other than these two, I wrote all the elements from the set A cross B. Then what is the relation here? See, what type of relation here? Here also, x comma y, see, such that x belongs to A, y belongs to B. What is the relation between first and second element of the order pair? See, here, x divides y. Y is divisible by x. It means what? There is a common relation in all the order pairs. Okay, common relation in all the order pairs of elements. First element and second element. There is a relation between first and second element. Here, what is the relation? X divides y. X divides y. See here. 1 divides 2, 1 divides 3, 2 divides 2, 3 divides 3. But here 2 not divides 3. That is why I didn't write here. 3 not divides 2. That is why you cannot write 3 comma 2. Only these 4 elements you have write. And it means what? Relation is set which is subset of the Cartesian product. There is a common relation. There is a common relation in all the order pairs. Common relation in all the order pairs. In that common relation is first and second element of the order pair. X divides y. You can write one more relation from the set A cross B again. You can write more number of relation on this Cartesian product. Only one Cartesian product. So you can try yourself also. Again, I want to write one more relation. R4 equal to R4 equal to 3 comma 2 only I write here. I will write only 3 comma 2. What type of relation it is? R4 equal to xy such that y equal to y equal to x minus 1. X belongs to A, y belongs to B. What type of relations here? X is greater than y by 1 or y is less than x by 1. What type of relation? Only this all elements should write. Whatever the relation you are writing here is a subset of the Cartesian product. You have to write all the order pairs which are satisfying this relation. Then only this is called a relation. Okay. You can write one more. R5 equal to see 1 comma 2, 1 comma 3, 2 comma 3. Only I write. What type of relation again it is? R5 equal to C x y such that x is less than y. X belongs to A, y belongs to B. See here, what is the relation? Still, I didn't give definition. Okay, by taking one example, you will write a definition. What is the Cartesian product? As you know already, R relations are subset of Cartesian product of A and B. Then R is a relation from the set A to set B. Okay. Then what is the set? So what is the relation? Relation is the first of all it is a subset of a Cartesian product. R is the subset of Cartesian product having an order pairs. In that order pairs, that first element is related to second element. That all the order pairs have common relation. In that elements of the order pairs have a common relation, gives a relation. Then how many relations are formed of A having 3 elements, B having 2 elements? One common formula is there. See, if R is a relation from set A to B, the number of relations from A to B is if n of A equal to P, small p, n of B equal to Q, then number of relations from A to B is 2 power PQ is the formula. This is very important. See here. If n of A equal to P, n of B equal to Q, then number of relations from set A to set B is 2 power PQ. 2 power PQ. For example, if you take this set, these two sets, if A having 3 elements, B having 2 elements, the number of relations from A to B, how many relations you can form the set having 3 elements, B having 2 elements is 2 power 3 into 2. This is equal to 2 power 6. This is equal to 64. Yes, okay. Here I wrote only just 4-5 relations. You can write 64 relations from the set having 3 elements and B having 2 elements. In that, first element divides second element divides first element is greater than second element is greater than first element is greater than or equal to second element is greater than or equal to first element. Therefore, you can write so many relations on the given set. That what is the formula? So to find the number of relations from set A to set B, 2 power PQ. Okay. For example, if you have A equal to 3 elements, B equal to 2 elements, number of relations from A to B is 64 relations. You can form. It is not easy to write down the relations. Okay, but you can find the number of relations from A to B. Now I want to define relation. What is the relation? Okay. By these examples, you can define it. First of all, R is a relation from non-empty set to non-empty set B. R is a Cartesian product. R is a subset of the Cartesian product. First of all, if you want to define R should be subset of Cartesian product. It means what? Without knowing Cartesian product, you cannot find relations. Okay, relation is a subset of Cartesian product of two non-empty sets. First condition. Second condition is what? That all the order pairs are defined as there is a common relation between first and second element of the order pair. Okay, just I want to write definition, then I will go to example. Yes. What is the definition here? Already you know what is the relation. A relation R from a non-empty set A to non-empty set B is a subset of Cartesian product of A cross B. First of all, it should be subset of Cartesian product of two non-empty sets A and B, and it is derived, it is taken by describing a relationship between first element and second element. First elements and second elements, first elements and second elements of ordered pairs in A cross B. This is the definition of the relation. Okay, very simple. Relation is a subset of Cartesian product. You have to take all the order pairs from the set A cross B which have a common relation between first and second element of the order pair. Very simple. R is a subset of the Cartesian product, and there is a common, we have to take some of the elements from the Cartesian product. They have a common relation between first element and second element of the order pairs. You have to write all the elements of set A cross B which have a common relation. Suppose if you not write any one of the element, then it not represents the relation. All element of whatever the relation you are defining, that relation is satisfying that elements of the A cross B, you have to write all the elements. Use the relation set. Okay. Relations can be represented by three methods. One is roster method, another one is set builder form, third one is arrow mark diagram. Okay. Again, I want to write one more example. I will describe here. I will discuss here. Suppose that question again, A equal to, I will take one more example, 1 comma 2, B equal to 1 comma 2 comma, I will take one more example better, 1 comma 2, 1 comma 2 comma 3, then A cross B equal to 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3. Okay, you write all the elements of the Cartesian product. I want to take R equal to sum of the elements from the set A cross B. Suppose I will take 1 comma 2, 1 comma 3, 2 comma 3. Okay, so R equal to what type of relation here? X comma Y such that X equal to Y minus 1 or Y equal to X plus 1, X belongs to A, Y belongs to B. Okay, so this is the relation I wrote in the set builder form, sorry, roster form. Okay, roster form means you have to write all the elements of the set R. So this roster form can be written in the set builder form as R equal to XY. Roster form is in general, okay. R equal to XY such that X equal to Y minus 1, X belongs to A, Y belongs to B. So in this way, I have to write that relation in the set builder form. This is roster form and it is set builder form. Roster form means you have to write all the elements which are satisfying same relation from the set A cross B. You have to write here set builder form, you have to write what is the relation between first and second element. One relation you can write into different forms also. Okay. And in general, how you can write the relation? R equal to, in general, here X comma Y such that X belongs to A, Y belongs to B, X is related to Y. This is representation of relation. Okay, R equal to XY such that X belongs to A, Y belongs to B, X is related to Y, and R is subset of A cross B. Okay, then how to represent it in the arrow mark diagram? This is roster form, this is set builder form, next is arrow mark diagram. As you know that what is arrow mark diagram in the set theory. I want to write here, see, A equal to 1, 2, B 1, 2, 3, R is a relation from A to B, R is a relation from A to B. So 1 is related with the 2, 1 is related with the 2, 1 is related with 3, again 1 is related with 3, and 2 is related with again 3. So you cannot write 1 comma 3 because I wrote Y minus 1, okay, this is not correct, okay. So 1 cannot be related with 3, sorry for that. Okay, 1 comma 3 cannot write because actually I am thinking that X is less than Y, that is why I wrote here actually, but afterwards what relation I wrote? X equal to Y minus 1 means So if you subtracting y by 1, it should be 1. 3 minus 1, not 1. Therefore, you cannot write 1 comma 3 here. Okay. So therefore, 1 is related with the 2, 2 is related with the 3. Okay. In this, you have to write arrow mark diagram for the relation. See, in this relation, that set A is called domain. This set A is called domain. Domain is the set which contains all the first elements of the R. First elements of the R. And second element, second set, this set B is called codomain. This is called domain of R, and this is called codomain. That whole set is called a codomain, and these only 2 and 3 are the related elements related with the elements of the domain, and this set is called 2 comma 3 is called range of R. What is the range of R? That all are second elements. Okay, second elements. This is the set which contains second elements of the order pair. 2 comma 3. 2 comma 3 here. The set of first elements of the R is called domain. That whole set B is called codomain, and only those elements of the set B codomain which are related with the domain is called range. Range is subset of codomain. Range is subset of codomain. And this 2 is called image of 1, and 3 is called image of 2, and this 1 is called pre-image of 2, and 2 is called pre-image of 3. Then what it indicates? This domain contains all the elements of pre-images, and this range contains all the elements of images. Okay, 2 and 3 are the images, 1 and 2 are the pre-images. Domain having set of all pre-images, range of set of all images. Range is a subset of codomain. Okay, this is the definition of relation. Are you followed? See a relation. First of all, you should know relation is very important. After that, once you understand relation completely, then only you can define a function, because function is also depend upon the relation. Okay, so only some of the relations are functions, or some of the relations are function. It means function is also relation. Okay, that is why first of all you should know perfectly what is the definition of relation. Then only you can discuss the function. Function is not easy to understand. There will be 5 marks question will come in the annual examination. That is why you should know what is the relation. Relation is a subset of the Cartesian product of 2 non-empty sets, and all the elements of the set are that in order pair. First element is related with the second element. All the elements of the order pair have common relation between first and second, or bond with the common relation. Okay, that gives the relation. Okay, so this is all about definition of relation. Now we have to discuss examples on relation. Okay, exercise 2.2. First example, exercise 2.2. First example, let A equal to 1 comma 2 comma 3 and so on 14. Define a relation. Define a relation R from a to a by r equal to xy such that 3x minus y equal to 0, comma x comma y belongs to a. Write down its domain, codomain, write down its domain, codomain and range. Okay, this is the one example or first example you can discuss. First, what they are given. Let a equal to 1, 2, 3, 14. Define a relation R from A to A. A to A means A to B. If you have two different sets, A to A means domain is also A and secondary set is also A. Relation from A to A by R equal to xy such that 3x minus y equal to 0. What type of relation between first and second element? 3x minus y equal to 0. X comma y are the elements of the set A. Write down its domain. You have to find domain, codomain and range. Okay, first, given that a equal to 1 comma 2 comma 3 up to 40 and r equal to x comma y such that 3x minus y equal to 0, x comma y belongs to a. Okay, so you have to find r from the set A cross A. Okay, what is the relation between? So this same set I write it as here. R equal to, you can write directly, or I want to change this relation as x comma y such that 3x equal to y, x comma y belongs to a. X comma y belongs to a. Okay, so I want to find relation from A. Okay, it means first, if you want to find R means you have to write Cartesian product because R is a relation from A to A. Okay, A to A means what? First, before writing relation, actually you should know what is A cross B. Here A cross A. Okay, because R is the subset of the Cartesian product. Therefore, not necessary to write the first time you are writing relation. That is why I want to write the Cartesian product. Cartesian product is not necessary to write here. Okay, first because you are defining R on set A cross A. That is why I want to write A cross A. A having how many elements are there? 14 elements. Okay. So number of elements of A cross A is 14 into 14. It is not possible to write all the elements. That is why I want to write some of the elements. You see here. What are the elements here? 1 comma 1, 1 comma 2, and so on. 1 comma 14. Next is 2 comma 1, 2 comma 2, and so on. 2 comma 14. What is the last element here? 14 comma 14. Okay, 14 comma 14 is the last element. In this, we have to write first Cartesian product. Okay, in that R is a relation. What type of relation here? 3x minus y means x. If you multiply 3, you will get y. Okay, x into 3 equal to y. Okay, therefore, see, first I will write it as first order. So R, see. If you multiply suppose if you take 1, okay, 1 into 3, 3. It means here what we have? Okay, 3. Okay, therefore I want to write here 1 comma 3. If you multiply x with 3, you will get y. Okay, suppose if you take x equal to 2, 2 3 the 6, so y should be 6, 6, 2, 2 into 3 6 y. And if you take x equal to 3, 3 3 the 9 here, 3 9. If you take x equal to 4, 4 3 the 12, 4 comma 12. So shall I write 5? Suppose if you take x equal to 5, 5 3 is 15, means y equal to 15. Okay. So y equal to 15 is y equal to 15. Can you write here? Last is what? 14 comma 14 is there. Suppose here these are all elements from set A cross A. 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. All elements from set A cross A. Suppose if you take x equal to 5 is there. Okay, x equal to 5 you have here, but a 5 comma 15, 15 is not present in the set A. Therefore, 5 comma 15 you cannot write. Okay, are you followed? See here how you can write it. X comma y, 3x equal to y. If you multiply this first element by 3, you get y. 3 into 1, 3. 3 3 is 9, or 3 4 is 12. Okay, actually next x equal to 5 you can take here, but 5 when you will take that its image should be 15. 15 is not present in the set A. Therefore, only we have these four elements. Therefore, R equal to 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. Okay. Then what is its domain and range? Okay. Domain of R. Domain of R equal to, it is a set of all first elements 1 comma 2 comma 3 comma 4. 1 comma, because domain is nothing but all the first elements of the order pair 1 2 3 4. Okay, codomain are equal to, codomain is all the set 1 2 3 up to 14. Range, second elements, okay, 3 6 9 12. Okay, in this you have to calculate range. Okay, range is the set of all the second elements. Okay. Okay. In this way, you have to calculate domain, range, and codomain. Are you followed? R is the subset of Cartesian product of two sets, and domain is the set of all the elements of order pair. That is first place elements you have to write 1 2 3 4. Codomain. Okay. Codomain means that the second set of the Cartesian product. Codomain means you have to write a second set of the Cartesian product. What is second set? A cross A means second set is also A. That is why I want to write a codomain is whole set you have to write. Range. Range means that the set of all second elements of the order pair 3 6 9 12. 3 6 9 12. Okay. So these are the some of the examples of relations. Okay. So tomorrow we'll continue remaining examples on relations, that is exercise 2.2. Okay. Thank you.